Okay, so we've got we're going to consider everything modulo n, and I defined the order of A, where A and n are relatively prime, equals the smallest k, or the smallest non-zero value of k, such that A to the power k equals 1 modulo n. Yeah, and we've established that, well, we know that A to the power phi of n, phi being the totient function, equals 1. That's Euler's theorem, we know that. But there might be a smaller power that will do. So we also proved in the last screencast that k divides phi of n. So we know that A to the power phi of n equals 1, but there might be a smaller value that will do with A to the k equal 1, and then we say that the order of A equals k, everything modulo n, and throughout a n equals 1. Okay, well let's have a think about this. Let's have a look at... We've established that if we were having a look at modulo 13, and we considered the order, or we worked out that the order of 2 modulo 13 was equal to 12. In this case, so the order of 2 is sort of maximal, because it can't be any bigger than that. And so we say that 2 is a primitive root of 13. Now there might be others. There might be other primitive roots. So 2 is a primitive root because 2 squared, 2 cubed, blah 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 blah, 2 to the power 11, 2 to the power 12. They all trace, I guess there's a 2 to the 0 as well there. These trace out the numbers 1 to 13 in some order. Sorry, 1 to 12 in some order. And we did that last time. Let's work out the order of 3 modulo 13. Let's just try that. So we're going to go 3 squared, 3 cubed, and so forth. We're going to multiply by 3 each time. That's 9. That's 27, which is 1, of course. Just check that. 3, 9, and 27, which equals 26 plus 1, which equals 2 times 13 plus 1. So 3 cubed equals 1 modulo 13. So therefore, 3 is not a primitive root of 13. Sometimes numbers have got primitive roots, sometimes they haven't. You can show that all primes have got a primitive root, but how many primitive roots does a number have? We don't know. It's very difficult to tell. But we do know, well, no, it's not entirely difficult to tell because I'll give you a formula for it, but it's not immediately obvious how it works. I'm going to stop there and answer that question in the next screencast.